arithmetic. What is fundamental theorem of arithmetic? We have this theorem in the first chapter, real numbers. Actually, sometimes the question will be define fundamental theorem. Means all you are confusing about this. Fundamental theorem nothing but just already you know the prime factorization. Do you know the prime factorization? That only see once you check the definition. Every composite number can be expressed as a product of primes. Every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. What is the meaning of this? Every composite number can be expressed as a prime number. So you can take any composite numbers. Already you know what are the prime numbers and what are the composite numbers. What are prime numbers? A prime number is a number which having only two factors, one and itself. Composite number means a number which having more than two factors is called as composite number. One is not a composite number, not a prime number. Now, what are the prime numbers? 2, 3, 5, 7, 11, 13, 17, 19. These are all of the prime numbers. Now, here what is the question? Here what is the theorem? Every composite number we can write, we can express it in the form of the product of A, express the product of the primes. For example, I am taking 12. Yes, 12 is composite number or not? Yes, it is having more than two factors. Yes or no? What are the factors? 1, 2, 3, 4, 6, 12. These are all of the factors. It having more than two factors. So that's why 12 is a composite number. Now, according to this theorem, this is the composite number. This composite number we can express it as a product of primes. How can you write as a product of primes? Yes, we will use the prime factorization. Okay, to do the prime factorization, divide by the prime numbers. See, first prime number is 2. I am dividing with 2. Okay, 2 6 are, how much? 2 6 are 12. Next, again it is divisible by 2 or not? Yes. So 2 3s are 6. Now 3 is a prime number. See, now how can you write this 12? 12 you can write as 2 into 3. 2 into 3. See, 2 is a composite number. This composite number I written as 2 into 3. Nothing but, see, expressed as a product of primes. See, 2, 2, 3 are the prime numbers. I written as a product of what? Product of primes. This composite number I written as a product of the prime numbers. This is called as what? Fundamental theorem of arithmetic. Understand? Fundamental theorem nothing but like it is a prime factorization method. Prime factorization. Every composite number we can write, we can express it as a product of prime numbers. You can take any number. You can take any number, we can write every composite number you can write as a product. For example, if you take 6 is a number. Can you write a product of prime numbers? Yes. How can you write 6 is equal to 2 into 3? 2 3s are 6. Suppose if you take the prime number, suppose I am taking 13. 13 is a prime number. Okay, this prime number we can't write as a product of the prime. Okay, just we will write a product of primes. You can write what? Prime number nothing but it having only two factors, number itself and 1. So this how can you write 13 1s are 13? This 13 you can write as only 13 into 1. But remaining composite numbers you can write as a product of every composite number. You can take any composite number, you can write as a product of primes. You will take one example for the composite number. You take any composite number, can be write as a product of primes or not. For example, I am taking 100. 100 is a composite number. Can we write 100 as a product of primes? Yes. Right now, first I am factorizing this. 2 is divided by 2. 2 5s are 0. 2 50s are. It is 100. Next is 2 25s are. 2 25s are 50. Next, is it divisible by 2? No. 25 is not divisible by 2. 2 completed. Next to prime number. Next prime number is what after 2? 3. Is it divisible by 3? No. So next prime number is 5. So check with 5. Is it divisible by 5? Yes. 5 5s are 25. Now last one is 5. It is already a prime number. Now see 2 2 5 5. These are the prime numbers. So how can you write 100? You can write as 2 into 5 into 5. See here 2 into 5 into 5. The composite number I written as 2 into 2 into 2 into 2. The product of the prime numbers. So this is called the fundamental theorem of arithmetic. Fundamental theorem, nothing but what? Every composite number can be expressed as a product of primes. And see, and this factorization is unique apart from the order in which the prime factors occur. What is the meaning of this? This factorization is unique. It is unique apart from the order in which the prime factors occur. For example, suppose if you take 12, how can you write? Suppose for 2 6 are 2 3. So 12, how can you write? 2 into 2 into 3. Suppose this 12 I divide with 2, 3 4s are 12, 2 2s. So what I got here? 12 is equal to 3 into 2 into 2. 3 into 2 into 2. See, the meaning of this factorization is unique and apart from the order in which the prime factors occur. See here 12, what you got? 2 into 2 into 3. Here 3 into 2 into 2. Is there any change? 2 2s and 1 3 is there. Here also 2 2s and 1 3 is there. Both are the same, but just the order is different. So that's why it is factorization is unique. Yes, these both are same. Unique nothing but these both are same. Apart from order in which the prime factors occur. We can take order is differently. You can write 2 into 2 into 3. Otherwise 3 into 2 into 2. Otherwise you can write 2 into 3 into 2 also you can write. The order is different, but the factorization is unique. You can take any factorization, any composite number, we can write as a product of the prime numbers. One more example, I will take this 72. 72. How can you write 72? 2 36 are. Next 2 80s are. Next 2 9s are. 3 3s are. 72. How can you write 72 is a composite number. 72 is equal to, how can you write? 2 into 2 into 2 into 3 into 3. See, if you multiply this again, you will get 72. Once you check it, 2 2s are 4, 4 2s are 8, 8 3s are 24, 24 3s are 72. Okay, this is the composite number. Every composite number we can write as a product of the prime numbers. This is called a fundamental theorem. LCM of fractions. LCM and HCF of fractions. How can you find LCM and HCF of fractions? See that example. The formula is LCM. Okay, LCM of fractions is equal to, what is the formula? LCM of numerators. LCM of numerators divided by HCF of denominators. HCF of denominators. LCM of numerators. The LCM of fraction, how can you find? LCM of numerators divided by HCF of denominators. What is HCF formula? HCF is equal to HCF of numerators. HCF of numerators divided by LCM of denominators. LCM of denominators. These formulas we use. Okay, what are the formulas? LCM is equal to LCM of numerators by HCF of denominators, and HCF is equal to HCF of numerators by LCM of denominators. Suppose if we ask the LCM, for the numerators you do the LCM, and for the denominator you have to do HCF. If we ask the HCF of any fractions, you have to do the HCF of numerator and LCM of the denominator. What he is asking, LCM or HCF? Okay, that one you have to do the, for the numerators, the opposite. Means if LCM opposite HCF, you have to do for the denominator. If you ask HCF, find the LCM of the denominator. These are the formulas we use while doing LCM and HCF of fractions. What is the LCM of fraction? LCM of numerators by HCF of denominators. And what is the HCF? HCF of numerators by LCM of denominators. We will take one small example to find this. Let's understand formulas. LCM of numerator by HCF of denominators. HCF is equal to HCF of numerators by LCM of denominators. Now we will take one small example. Let take one example. Find LCM of LCM of 8 by 25, 8 by 25, comma 4 by 5. What is the question? Find LCM of 8 by 25, comma 4 by 5. Fractions given 8 by 25 and 4 by 5. These are the fractions. How can you find the LCM of the fractions? How can you find the LCM? We have formula. What is the formula? LCM of fraction is equal to LCM of numerators. LCM of numerators. LCM of what are the numerators here? 8 comma 4. LCM of numerators. LCM of 8 comma 4 divided by HCF of denominators. HCF of denominators. What are the denominators here? 25 comma 5. Denominators are 25 and 5. LCM of 8 by 25 and 4 by 5. How can you find? LCM is equal to LCM of numerators by HCF of denominators. The numerators are 8 and 4. So LCM of these 8 by 25 and 4 by 5 are LCM of 8 comma 4 by HCF of these denominators 25 and 5. Now what is the LCM of 8 and 4? You do the LCM 8 and 4. How can you do the LCM? 2 4s are 2s are 2 2s are 2 1. So what is LCM? LCM is equal to 2 into 2 into 2. 2 2s are 4, 4 2s are 8. So what is the LCM? 8. So LCM of 8 comma 4 is equal to how much? 8 divided by HCF of 25 comma 5. HCF we have to find. So what is the HCF? 5 into 25 by using division method. 5 5s are 25. Remainder is 0. Now what is the answer? Not this question. This divisor is answer. What is the divisor here? 5. So what is the HCF? 5 is the HCF. So the denominator is 5. Now what is the answer? 8 by 5. The question is find the LCM of 8 by 25 comma 4 by 5. Fractions. How can you find the LCM? LCM of numerators by HCF of denominators. Okay, HCF of denominators. So first find LCM of the numerators 8 comma 4. 8 and 4 LCM is what? It is 8. And the denominators are 25 and 5. HCF of 25 and 5 is 5. So what is the answer? 8 by 5. Is it clear how to find the LCM of fractions? LCM of numerators by HCF of denominators. Now for the same example, I am finding HCF. Okay, finding HCF. Now question is find the HCF of 8 by 25 comma 4 by 5. 8 by 25 and 4 by 5. How can you find the HCF? What is the rule? The rule is HCF of the fractions is equal to HCF of numerators. HCF of numerators. What are the numerators? 8 and 4. HCF of numerators divided by LCM of denominators. LCM of denominators. What are the denominators? 25 comma 5. Numerators 8 and 4, denominators 25 and 5. So HCF is equal to find the HCF of numerators and LCM of the denominators. So find the HCF 8 and 4. 8 and 4. What is HCF? 4 big number is 8. By using division method, 4 2s are 8. Now you got the remainder 0. So what is the HCF? Divisor, this is 4. So HCF is equal to HCF of 8 comma 4 is 4 divided by. Next, in denominator, LCM of 25 and 5. LCM of 25 and 5. What? 25 comma 5. So LCM 5 5s are 25, 5 1s are 5. So already it is a prime number. LCM is equal to 5 into 5. 5 5s are 25. So LCM is how much it is? 25. So it is how much it is? 25. Now what is the HCF of 8 by 25 and 4 by 5? 4 by 25. How to find it? HCF of numerators divided by LCM of the denominators. Numerator first find the, he is asking HCF, find the HCF, so HCF of numerators. Next one is denominator LCM. Suppose if the question is LCM, find the LCM of numerator, denominator HCF. Like this, we can find the LCM and HCF of the fractions. Okay, thank you.